Okay, in today's class, we're going to look at average value, and there's some really cool GeoGebra applications that allow you to visualize what's happening. So when you're thinking about average value, you've got to understand that you're looking for something different to average rate of change. Okay, now here's a function pictured. So I've got x squared multiplied by x take 6 all squared. Now, what I'm looking for is the average value of the function between 0 and 6. Okay, now remember the function produces infinitely many y values between 0 and 6. And if I look at all the y values that it can produce, what would it be on average? Now you can see here that it goes up to 80 and then it goes back down again. Okay, so like if you think about some of the values that are produced, like here's 120 to 40, etc., etc. What I'm thinking here that will happen is that the average value of this function between 0 and 3 would be roughly the midpoint here would be roughly 40. Okay, then back down here, again, the average value will be roughly 40 on the other side. Now, a great way to visualize this is to think about this like, imagine a line drawn at x is equal to 6, and think about this like ice melting in a container with a line blocking the fluid along here. Now watch what happens when I move this slider here. You can see here what happens is the ice starts to melt. There goes the ice melting away, melting away, melting away, melting away, until it produces this fluid. Okay, and you can see here that the average value of the function is roughly 43.2, which is, sort of what we anticipated. We can see it with other functions as well. So here's an example here. The average value for this one will be a little bit tougher to pick. So between 0 and around about this point here, which is 6, I think the average value would be a little bit higher, but then these values here will pull it back down a bit to, so I think it's like going to be 4 from 0 to 2.5. Then it's going to go a bit lower because the average goes down, so maybe between 4 and 3. That's my prediction. Okay, so again, imagine a line drawn here, and this is ice melting. Let's see what the ice goes down to. Not a very good prediction there by me, and it's sometimes difficult to predict what it actually is. Okay, so there we go. The average value is 4.6 recurring. Let's do one final one. So here we go. We've got a linear function here, and we've got an area of 10. Now, I know exactly what this is going to be. So I know for a fact that the average value of this will be 10 multiplied. So what by what? 4 times what will give me an area of 10. That's going to be 2.5. So I think the average value here is going to be 2.5. Let's see what happens. There we go, 2.5. Okay, now how did I know that the average value would be that without doing this process here? Well, let's get stuck into it and see how this actually works. Right, so first of all, don't get confused between finding the average value, that thing there, and the average rate of change. Okay, so they're not the same thing. So the average value of a function f with the rule y equals f of x over an interval is defined as this. So essentially what this is saying here is that you integrate the function as normal, and then what you do is you multiply it by 1 over the subtraction of the terminals. Now, how does this work in practical sense? What it is and what you want to do is find the area under the curve. Okay, so that's what you're finding is this area here, the area under the curve, and then you simply will multiply it by b take a, which will give you this part here. B take a will actually give you the length of this, okay, and then again what we know is that this is the area here, okay, and what we're after in each of these cases is the height. Okay, so in terms of the graph of y equals f of x, the average is the height of a rectangle having the same area as the area under the graph for the interval AB. Okay, so that's what's going to give us the height. All right, so let's try one out. Find the average value of f of x equals x squared for the interval 0, 2. So let's just think about what x squared looks like. There's 2 there. So we're looking basically for the average value of the function between 0 and 2. Okay, so we know that that's up to 4 there. So the average value is going to be somewhere between 0 and 4. Okay, and again, what you want to do is imagine this as like ice melting, which will come down to an area of that, something like that. Okay, all right. So what I'm going to do first of all is just integrate to find the area under the curve. So integrate between 0 and 2, f of x dx, which is x squared dx, which is x to the 3 on 3, between 2 and 0, which is 8 on 3 units squared. All right, so basically what I know is that this area here totals 8 on 3 units squared. Now, what's this going to be? Well, that's going to be this length here, which is 2 take away 0, which is 2 take away 0, which also happens to be the subtraction of the terminals. So this is going to be 2, and the average value will be the height of this. All right, so let's go back to year 7 and go area equals length by height. I've got the area, which is 8 on 3, and I've got the length, which is 2 times height. The height is going to be 8 on 6 when I divide both sides by 2, which equals to 4 on 3. Okay, now that means here that I've found the area under the curve, okay, and then I just simply need to multiply this value here, so to get the average value, so average val, all I'm going to do is multiply by 1 on 2, okay, so equals 8 on 3, which is the area, multiplied by 1 on 2. Now, why 1 on 2? Well, again, part of the formula is this part here, 1 over b take a. I've got to grab this area here and multiply it by 1 over whatever the subtraction of the terminals was, which is 1 over 2, okay, which gets us to 8 on 6, which is also 4 on 3. So notice here that I've got the exact same answer, and what the formula does is basically just does this process. It eliminates you having to think about it like a rectangle and transpose it. It just allows you to go straight through and find that average value. Okay, now remember the average value is just that, it's a value, so we don't need to put units on that, unless it's got some context. All right, now what is the average rate of change between 0 and 2? Well, that's just the straight line or the gradient of a straight line joining those 2 points, which is completely different to an average value. This says on average, overall, the function would produce 4 on 3 as an average, but the average rate of change just says the gradient between these 2 points is. So again, totally different concepts. All right, so to get the average rate, we're going to say that average rate, which is different from average val, equals f of 2 take away f of 0 over 2, which is, our function is x squared, so it's going to be 4 take away 0 over 2, which is equal to 2. And again, that's a rate, okay? So we'd consider giving that context if it was applied, okay? So again, notice that these two answers are different. This is the average rate of change. This is the average value of the function. All right. Let's do this one after this question here. Okay, so question 18, the average value of the function, this function here, it's a hyperbola over the interval 0 to k, is 1/6 log E7. Okay, so 1/6 log E7 is going to be the answer. And let's get the average value, okay, over the interval 0 to k. So we're going to integrate between k and 0. Because we want the average value, it's 1 over the subtraction of the terminals, k take away 0, which is 1 over k. And what am I integrating? It's 1 over 2x plus 1 dx. Okay. Um, 1 over k square brackets, and the integral of that is 1 over 2 log E 2x plus 1, and that's between k and 0. Okay, now I've got 1/6 log E7 equals 1 over k. Let's jam k in, so I've got half log E 2k plus 1, take away, when I put 0 in, 0, 1, log E1 is 0, so that's going to be just take away 0, so I'm not going to bother. Okay, now let's multiply this out. So I've got 1 over 6 log E7 equals 1 over 2k log E 2k plus 1. Now what we can do is we can just equate these off because this is the same as this. We can either let them equal each other or let them equal each other. Okay, I'm going to go with the thing being logged. I'm going to say that 7 equals 2k plus 1. 6 rather equals 2k. K is equal to 3. Or I could say that 2k is equal to 6, in which case k is equal to 3. There's our answer there. Okay, so this is certainly a tough question from 2013 exam 2. Let h be a function with an average value of 2 over the interval 0 to 6. So basically we're saying the answer or the average value is 2, 1 over subtraction of the terminals, 6 integral 6, 0 h of x dx. This is what's going to happen. Okay, when I find the average value of a function between 6 and 0, and multiply it by 1/6, I get the average value of 2. Okay, so remember what that means is the average value is the height of a rectangle, okay, drawn between the endpoint, which is x is equal to 6. So it's saying that the rectangle would have a height of 2. Now you can see fairly quickly that this would not work out for this function. It's not going to produce a height of 2 because, again, if you imagine this like a big bit of ice and a big bit of ice, and if it melted, what would happen is this cap would drop into that spot. And that would indeed produce 2 as an answer. But at the same time, this would also melt and it would start filling up past 2. So this has an average value greater than 2, this function. All right, let's imagine it for this one here. So we're going to cap it there. This is what we want. We want the average value to be 2. And fairly quickly you can see that if I put this part into there and this part into there, it's going to fill much past 2. So this is greater than 2 as well. Okay, this one here, let's draw it in, noting that it needs to go all the way to 6 there. Now, this looks a little better. Okay, this bit is going to slot in there quite nicely. This bit will slot into there quite nicely. Then what's going to happen is we've got this empty space here in the trough, if you want to think about it, or whatever you want to call it, which means that the water will then seep down a little bit lower. So this has got an average value less than 2. All right, over here, well, what we're going to consider here is if this is an area here, we're going to go 6 times 8, which is 48. Let's half 48, which is 24. So this area here would be equal to 24. So area is equal to 24. Now we want the average value to be 2. Okay, so one way to consider it is if you look at it visually, no way can I put that into there and have like the water level stay at 2. But the other way to think about it is, well, what would the average value of this function be? Well, I actually can work this out, okay? So it's going to be the height here, so 6 multiplied by what value here, the height, to equal 24. The average value of this one here is actually going to be 4, okay? So you can see that that bit there, when slots in there, will give us a height of 4. So that means that this must be the correct answer, okay? And the question is why? Well, this is well written, this question. So let's consider the area under this curve here. So again, we've got a height of 8 and a width of 6. 6 times 8 is 48. Half of 48 just like before, is 24. So this covers an area of 24. Now what we want to do is consider a rectangle, and it's going to be 6 times 4. So 6 fours will give me, so it's going to have a height of 4. The rectangle is going to have a height of 4. And notice that 4 onto -2 will give us an answer of 2. So this will be our area here, or the height of a rectangle that allows us to get that area of 24. Okay, so that's why that one will produce an average value of 2. Extremely difficult problem and requires you to really have an intricate understanding of average value.